Hey everyone. I think that last week having a video to accompany the notes was kind of helpful to visualize what the error metrics in the case of a regression application look like. And so it's worth doing one to discuss the performance metrics for classifiers as well. I think the best way to do this is to break the video or a series up into three separate videos. The first one here is just going to talk about what is classification? What's the objective here? How does it work? I think that's important because with regression, I think all of us have an idea about what regression is. We've all seen forecasting before, building a line of best fit to make predictions about a numerical quantity in the future. But we haven't necessarily seen a classification problem before. And so here in this video, we'll talk about what classification is. I'll have a follow-up video that builds several different classification models using a classification scheme that we'll introduce here. And then I'll have a third video that comes back and talks about the error metrics for those models. And so I hope you'll join me for this series of three. I think the last video in particular will be useful. But here's, again, just a short discussion on classification. So you see the plot here that I have on my screen. I've got three classes of points. I've got red points, I've got blue points, and I've got green points. The goal of a classification problem is to draw fences or draw regions that separate these points. And so one way I might be able to classify my points here, I've made up kind of an easy problem, is to say, well, let's just draw a fence here and say everything above that line should be red. And then let me draw another fence here. And we'll say, well, everything to the left of that line should be blue and everything to the right of that line should be green. And at this point, we have a model. The model comes in the form of those boundaries or of those fences that separates our data. This is a classification model. The goal of classification is to use an algorithm to fit these fences. And so that's what we're up against. So one way is the way that we've just looked at. These decision boundaries could be created by building what's called a classification tree. And we'll look at classification trees later in our course. But throughout the second and third videos here, we're going to use a different type of classification algorithm called k-nearest neighbors. And I want to take a minute here just to introduce k-nearest neighbors to you. So the way k-nearest neighbors will work is we have to define what k is. K is going to be the number of voting neighbors for classifying a point in space as belonging to a particular class. So if we define k equals 3, what that means is when I look at a point in space, like maybe this one, for that point in space, I'm going to look to the 3 closest training data points. So 1, 2, 3. And I'm going to allow those 3 data points to vote on the color or the class that this region of space should belong to. Now, the most popular class is going to win. And so this data point here would be classified as red. Similarly, if we move to another point in space, let's say there, let me move it just a little bit. Let's say we're here. Then I'm going to look at the 3 closest data points in my training data set. And now that point is also red. K-nearest neighbors will do this with every point in the background. And that will help us draw a model. Now, if we change the value of k, it's possible that we could get different classifications. So if we change k here to 7 and look at that most recent point we classified, well, we're now going to look at the 7 nearest neighbors. So I have the 3 drawn. That's 4. That's 5. I think that'll be 6 and 7. But now we have 3 red neighbors and we have 4 green neighbors. This point would be green. And so depending on the value of k we choose, we're going to get different boundaries drawn and different classification schemes. But so just to recap, and this video will be short, our goal here is to classify points by drawing fences. The way we draw fences is determined by the type of classification algorithm we use. And so let's cut this video off here. Let me know if you have any questions about classification or what our goal is. And I'll see you in the next video where we actually construct a few k nearest neighbors classifiers. Thanks, everyone.